Hello everyone, this is Julian at Mecanum, and today I'm going to do a quick characterization using Fomic software. We'll start by creating a project. I'm in Fomic's interface. I have a few choices. I will choose inverse method, equivalent fluid. And for today's demo, I measured 11mm felt with an impedance tube. If you're not familiar with impedance tube measurement, I recommend you to watch our video on this topic. But for today's demo, what you need to know is that you can simply import your TubeX project in a few clicks. And there we go. All my measurements are here. As you can see, I did quite a few measurements. Okay, I will start by selecting my hard wall measurement. There we go. As you can see, I have some variability. This is on my sample were not exactly the same thickness, but that's not a matter for the software. It can deal with that without any problem. Now if I go on my parameters, I can see there are two different types of frame. So here I will leave it at general to avoid simplification. I have different type of frame, rigid, limp, hybrid. And here in the main window, you can see that if I already did some characterization, I can write down the result here. It will improve the precision of my inversion. But for today's demo, we'll just leave it empty and see what the software can get for us. Can compute, and there we go. As you can see, I have my result right here, my equivalent fluid parameters, and the simulation is right here. Can now go have some fun in the simulation module. I can add as many simulations as I want. So here I need to enter the thickness. Here I will enter my sample thickness, but I could enter any kind of thickness, and I will run a simulation. Okay, let's see what happens if I go to 10,000 Hertz. Okay, unlock, and now I can compare it to my measurement. Right. And now I can also add an air gap. Let's see what it gives. I will lock my graph to keep on my curve. And there we go. I have my material with a 30mm air gap. And now I can also compare it to my result because I did the characterization on 30mm. And as you can see, there is a pretty good agreement between the simulation and the measurement. Of course, it's not perfect. I could always continue to improve it or do some direct characterization, but for a quick characterization, it is fairly good. So that's all for today. I hope this video was useful for you. Thank you very much for listening, and see you soon.